All right, what do you do when the angle that you have is not one of your reference angles? Obviously, there are more angles than just 30, 45, and 60 degrees, and certainly 90 and 180 and 360 and 270 and all of those. So what do we do when the angle is not one of our reference angles? And that's what we want to look at today. First of all, let me just say that at this point, without a calculator, they'd have to give you some other information. And so given that the CLEP may ask a question pertaining to sine, cosine, and tangent, in which refers to something not one of your reference angles, we need to keep that in mind. They'd have to give you some other information. So as a slight comfort to all of you, hopefully that helps. But how do you approach it? So let's talk about it. First of all, let's remember that cosine is always the x-coordinate, and sine is always the y-coordinate. So here we have a question. If sine of pi over 9 equals 1/5, now let's find some other information. So the first thing that helps is, obviously they're giving me some information. They say to me sine of pi over 9 equals 1/5. So if I was to put this onto this graph here and say, okay, this is pi over 9, when it tells me that the sine is 1/5, we understand that sine, yes, it's the y-coordinate, but sine is also known to me as being opposite over hypotenuse. So if we see it in the form of a fraction like this, this is really saying that I have 1/5. In other words, they're telling me that the radius is 5 right now, looking at that. And so in order to continue on, and before I even get to all these angles, I want to just tell you, the first thing that you have to do is figure out what x is. And so how do you suppose I'm going to do that? Pythagorean theorem. And so just off to the side, we're going to do 1 squared plus b squared, or x squared, equals 5 squared. So 1 plus b squared equals 25. So b squared equals 24. And therefore, we're going to take the square root of 24. I hope we're all following this so far. And recognize that 4 is the largest perfect square that can come out. And I end up with 2 square root of 6. Once again, this is technically plus or minus. And the plus or minus allows me to see which quadrant we're in. So we have 2 root 6. So the first step is to find the missing side. Okay? Find missing side. All right. Step 2 in this whole thing is to put it on the unit circle. Put on the unit circle. Well, how do you mean by that, Mrs. Madison? Well, what I mean is we need this to now equal 1. And so since it's 5, I would have to divide by 5. And that means I divide all of the sides by 5. And that would give me what this side actually is, what this side is. And you can see once again that the sine is 1/5. And the cosine would be 2 root 6 over 5. Pretty simple process, right? I hope that makes sense to you. All right, so now we can basically determine what the sine is of a function, what the cosine of a function, just by looking at this triangle. But you'll notice that the first question they ask is not about pi over 9, but is 8 pi over 9. So now what our job is, and I'm going to just make sure I switch the colors here, is to understand where it's placed on the unit circle. So I'm going to put place on unit circle. And what I mean here is we need to understand where is 8 pi over 9. Well, some of what makes this a little easier anyway is if you think about, okay, 2 pi, let's put this with a denominator of 9. Since these are over 9, it only would make sense that we can kind of put them in perspective of what it would be over 9. And of course, this would be 18 over 9. Pi then would be 9 pi over 9. Doesn't that make sense that those are still equal? All right, well, what about over here? Because you can't make the denominator equal to 9, right? Because 2 doesn't go in there easily anyway. And so another option would be, all right, well, could we put that into something else that's maybe close to that, maybe 18? And if you look further down, you'll see some of the questions actually involve 18. And so it would only make sense. That would mean we do 9 pi over 18. Certainly, you could write this as 4.5 over 9, but it's not as obvious. And like I've said in the past, we don't typically see decimals with the fractions like that. So this just gives us a little perspective. So just like I did here with 9 pi over 18, this would be 18 over 18. This would be 27 over 18. This will help us as we go around. So we've placed things on the unit circle. So now as I start to do this question, and it asks me for 8 pi over 9, I see 9 pi over 9, so that must mean 8 pi is just 1 pi over 9 shy of that. Doesn't that make sense? Now as you look at these triangles, I want you to observe that there's always a short side and there is always a longer side. So if this is how the angle was positioned originally, you can see that the short side is right there is 1/5. In other words, I can see the short side is 1/5. The longer side is 2 root 6 over 5. Recognize that's negative because it's a negative x, right? And so if instead I said 10 pi, so I should answer that question. What's the sine of 8 pi over 9? Well, the sine of 8 pi over 9, still the y, is 1/5 still. The sine of 10 pi over 9, the only difference to that would be that it would go one beyond 9 over 9, and so it would be found here. So that's just negative 1/5 because it's now going down. Still that short side, correct? How about 17 pi over 9? Well, we know 18 is over here next to 2 pi, so 17 would just be on this side. And again, with asking about sine, it's going to be this, and of course, is that positive or negative? And of course, is negative 1/5. All right, now let's look at 11 pi over 18. Well, we can see where 9 pi over 18 is, so 11 pi over 18 would be just on this side. And you might say to yourself, but wait, that's 2 pi over 18 extra. Right, but what's 2 pi over 18? 2 pi over 18 is 1 pi over 9. In other words, they're telling you that this is pi over 9 away from that. Okay, now let's get a little perspective. I told you that there's always a short side and a long side. Do you see the short side has just moved to here? That's 1/5. And this is 2 root 6 over 5. But when they ask for the sine is always the y coordinate. So the sine of it this time is 2, I just lost space here, 2 root 6 over 5, and it is going up. And the cosine of that would be 1/5, except it would be negative because it's going to the left. Now, I probably would just take at this point for you to encourage you to actually watch this a couple of times, or at least to review parts that might be of confusion. Certainly write down any questions that you might have. We're going to do another example of this, probably a few examples of this tomorrow in class, but this just gives you a slight introduction on how to handle when you have an angle that is not one of your reference angles.